Alrighty, in number 4 in the Freefall worksheet, we're going to go ahead and take a look at how to do this problem. So you throw a ball straight upwards with a velocity of 15 meters per second. So you are going to throw it straight up into the air. It's going to go up, it's going to get to the top, and it's going to come back down. Now, that means that the velocity it started with is 15. But the question is asking about the maximum height of the ball. And so the end, or what I'm going to look at for my V and like V and X, is at this maximum point. So this is where X is going to happen. And that's going to be at some height above the ground. And then I also need to think about what the velocity is there. So what is the velocity at the top? So this is also going to be V is velocity at the top. Now, if we're just thinking about the velocity at the top, what I want to think about is it starts going really fast. And as it goes up, it's going to get slower and slower. And as it's going up, if it's still moving upwards, then it's not at the top yet. And once it starts going down, then it's not at the top either because it's already moving down. Well, the in between going up and going down, at this point right there at the top, the velocity at the top will be 0. And so that means that this velocity at the top is 0. And then we already talked about how the starting velocity was 15. My starting height, I'm going to make this where x is equal to 0. So my starting height is 0. And then I don't know how high it gets. This is a good question. And then it's in free fall. So just like we talked about before, if you throw anything, it's not rocket propelled. There's no helicopter making it hover. Everything without air resistance will always accelerate downwards at 9.8 meters per second squared. So that means my acceleration is 9.8 meters per second squared. And because it's going down, and I said everything else going up was positive, then going down is negative. All right, so then in the first part of this, it says, what is the velocity at the highest point? Well, we just talked about that. That is 0 meters per second. And then it says, what is the maximum height of the ball? Well, the maximum height of the ball is going to happen at this point right there. So we need to know the maximum height, which is x. So we really want to have an x in it. So here's an x. The middle one doesn't have an x. That's not helpful. Here's an x. All right. So I really want one of those. I don't know them, but I really want one. And then I'm going to go through and highlight the things I know. I know the starting position. I know the starting velocity. I know the ending velocity is 0 at the top. I know the acceleration, but I do not know time. So if I am trying to decide which equation to use, one of the things I want to make sure I do is pay attention to which one I have all but the one thing. So this equation doesn't work because I don't have time. This equation doesn't work because I don't have time. So that means that I need to use this equation. All right, so now what I'm going to do is I'm going to plug in the numbers that we already figured out. So velocity squared, that's going to be 0 squared. Starting velocity is 15. I'm going to go ahead and plug all this stuff in. Alrighty, so I get 15 squared is 225. 2 times negative 9.8 is negative 19.6. And then I have x minus 0. Well, x minus 0 is just x. But at that point, I can just leave off the parentheses because it's just x. And so then I will have 19.6 times x. Now, I got to get x by itself. So the first thing I'm going to do is subtract 225 from both sides. So I get negative 225 is equal to negative 19.6x. And then the opposite of multiplication is division. So I'm going to divide both sides by negative 19.6. And I get an answer of 11.48. So then the next thing I need to do is I need to figure out how much time it's going to take to reach the highest point. Alrighty, so now we got a position of 11.48 meters for x, and so this is going to get plugged in here. So this is 11.48. And so now if we wanted to use position in one of our equations, we totally can, because now we do have these. And now I want to try to find time. So now I need to have one of these with time in it. Okay, well, this one's not helpful because that one doesn't have time. So I need to use the first one or the second one. Well, I will tell you, I do not feel like using a quadratic equation to solve the first one. And this one just looks really nice and easy. So I'm going to go ahead and use this one. And just like before, I'm going to plug in all the numbers that I have and solve for what I don't. So velocity is 0, acceleration is negative 9.8, time I don't know, I'll leave it as t. And then v naught is my starting velocity, that was 15. Now I'm going to subtract 15 from both sides because I need t by itself. And before I do the division, I have to do my addition and subtraction because of PEMDAS. And so I get an answer of 1.53 seconds for my time.